This coffee has got old and pretty cold, but I don't mind. I don't mind because I'm very excited. I'm hot inside. I'm hot for what's happening right now because I'm Christian and this is Lazy Devs, and we are still working on our Pico-8 tutorial and our Breakout, and things are starting to look pretty awesome. And that's because we are now in the part that is really fun, that is about particles. So if you watched, the last episode was probably the most important one, to some extent, because we had particles. Look at this. Look how beautiful our bowl is leaving particles. Ah, it looks so awesome. Look at this. Ah, man, I love it. Don't you love it? I love it. Like really nice fiery particles. And so now we're gonna see, oh, what else can we do with our newfound pals? Yeah, what can we do? So one thing I wanted to do is first I want to make our particles future-proof. And then what I want to do is I'm going to start applying particles on other things. So we have trails. Why is level set up here? Not sure what this is. Oh yeah, I know, I remember. Now maybe I want to tackle brick particles. So when a brick explodes into particles, I want it to burst into stuff. But first, let us take a look at our particles. I'm not exactly sure about one thing. It's just one thing. I'm not exactly sure. Oh, this 1.6 is. I think we want to be the particles more confined. Maybe just let's see if we can make them a bit more confined. Yeah, I like that. It's still. Now we get like this chunky pixels because the particles are very close together. So you might be wondering, oh, maybe those particles are too much. Maybe I'm creating too many particles. What if we want to have less particles? Well, the problem is like we're spawning a particle every frame. And if we sometimes don't want to spawn a particle, then we would do something like if rnd. Let's say we want to spawn on average every second frame, right? And then we're gonna go if rnd is smaller than 0.5, and then everything else in here. So now there is like a random number generator that is executed every frame. We're flipping a coin every turn, and then if it's tails, I guess, then we spawn a particle. If it's not, if we're not spawning particles. So on average, we're gonna get a little bit less particles. Maybe that's actually better. I like this actually because it's not as overpowering as it was before. I noticed that I actually don't want the particles to appear over the pills, so I want to draw first the particles and then the pills. So let us fix this. Oh, my girlfriend came back. Oh, I have to deal with her now. Oh no. So let's see. Actually, I love to deal with her. So pills, then particles. So now we're gonna draw first particles and then we're gonna draw pills. This is how we're gonna do this. Bricks. Now our particles are above the bricks. Yeah, because later on bricks will explode, and I want the mayhem to be real. Right. Okay, I like this. Maybe a little bit of here. Hi. Maybe a little bit of a. Oh yeah, that's. There's the gaps between the particles are too big. I think I want to go back to 0.5. Yeah, that seems better. Okay, so now that this is done, oh, I love it. This is already so much fun. Good. So now that this is done, I want to future-proof our particles because of the following problem. I like how we change the color of the particles. That's something that happens a lot. We want to change the color of the particles a lot. But maybe there's going to be like multiple colors that we'll be going through, not just like one, this and the other one. Maybe there's like a whole gradient that you want to be going through, like with the blinking animation here, it goes through multiple colors, right? So then we would have to add additional colors. That would be like really crazy and really inconvenient. So what I want to do instead is when I say a particle is a certain color, I'm not going to just set a color. I'm not going to just say one color. I'm going to give the particle an entire array. And this array can be multiple colors. And then the particle, as the particle ages, it will pick the appropriate color for from the array. So for example, if the array is just one entry, then the particle will stay this one color. But if the array is 2 entries, then it will be like this, whereas like at the midlife crisis, will switch to the different color. And if the array is 3 colors, then it will first start with one color, then around the then after a third of its life, it will switch to a different color, and then in the last third of its life, it will switch to a third color. So I want the color function here when we are spawning, when we're adding the particle. I want the color function, the call, this guy, I want this to be an array. And then that allows us to get rid of the old call, and we're gonna have a much more flexible particle all around. So we're gonna get rid of the old call, but instead we're gonna have something like call array, right? And we're gonna go. The particle will start at 0. We're gonna have dark particles. And we have like a call array. That's a color array for this specific particle. So when we're adding a particle here, we're gonna have to make sure that we have enough memory for this. Instead of the 10,9, we can just simply go here and like define an inline array. You can do this. You can just create an inline array, like here, 10,9. See, now it's like an array that we're giving to this particle, saying like first turn into 10 and then turn into 9. There's one more thing that we have to do, and that is I'm gonna actually have to check if I'm gonna have to change the color of the particle as we go. So let's see. Okay. Yeah. This is it, right? So let's think about this real quick. Can we do this? How are we doing this? Okay. So just let's just check one situation, like if so this is now an update function. We're gonna actually pick which color for this color array we're gonna apply to our particle. In a case when the color array, hashtag color array, when the length of the color array is 1, then the thing is really clear and we don't have to actually mess around. Then you know, we're just gonna set the color to the only entry in our array, and things are peachy. One, right? The first entry of the color array we're gonna put into a color, and we're not gonna deal anything. That's kind of like a nice, because a lot of particles will maybe just have one color, and that's fine. But if the color array is not, if p color array is 1, that's something I forgot. But in other cases, we're gonna actually have to do some smart stuff. So what we have to do is we're gonna go local underscore ci. We're gonna call it ci color index equals. We're gonna have to again divide our age through our maximum age to kind of like get a number from 0 to 1. And if it's 0, it's the particle is just has been born. If it's 1, it's at almost the age where it's supposed to be dying. And then we're gonna multiply this guy with, I mean, we can make it in multiple steps, so it's maybe it's more clear. So first we're gonna do this. So now it's a number between 0 and 1, right? That says how progressed, how how old the particle is in a number between 0 and 1. And then ci equals ci times, and now we're going to take the number. Oh, that's wrong here, right? I think this is hashtag color R. The number of entries in our color array, right? And then we're going to do a FLR, that's floor, because we only want integer numbers. So now we're tying the age of the particles to an entry from our color array. We'll multiply this age number that we had, this percentage number, so to speak, of the age. We multiply that with the number of entries in our array, and then we remove the number behind the comma to kind of like get which entry in our color array corresponds to the age of our particle. I think we have to do a +1 in here. Yeah, because the array starts as 1. Yeah. And then we can try to do this. I'm gonna do something else in a second here, but first let's see if this works. Like this, right? Let's try. So maybe it was hashtag after all. Yeah. Okay. Okay, so we're getting a problem where we're trying to access an entry outside of what it's supposed to be. That's bad, obviously. Let's use our debug function. There's something a bit wrong with CI. CI is accessing a value outside of what it's supposed to be. Obviously, we don't see it now. Oh, wait. There's something else. We're attempting to get a length of field call R, a number value. So somehow a number value got in our call R. How did that happen? We didn't put... What? 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 But how does this happen? Okay, let me try something. I'm gonna debug this. Clearly, there's something happening that is not supposed to be happening, so I'm gonna just do it like this. It's just number 1? What? Are we? I think we messed something up. Type max age call. Okay. Okay, got it. Max age. Got it. So there's for some reason there was one array too much. One entry array too much. Now it's a table. Okay, that's good. Whew, I was so the bug was in here, and when we actually adding the particles, we messed up the number of arguments, and so that's why it was like, wait, this is not a table, this is not an array. We're dealing with a number here. I cannot give you a little length of that crap, and that's why it was causing some issues. So now this should work. Yeah. See, now it looks exactly the way it looked before, but now we can, for example, very easily, without any kind of like adding any additional code, we can just add, oh, let's see what happens if we add a red on the end. That's 8, right? Oops. So let's. What if we got to add in red in here? And haha, we're gonna get a red as well. And now you can even go like, oh, but what if then it leaves smoke behind, right? So let's go like 5 behind it. Now you can create like a whole like rainbow of particle effects on the particles, which is really great. But you know, we're gonna keep this around for now. This is just future proofing our particle. This is not something that this is not how would I say it? This is not something that we need right now. We're gonna need it in a second. So big particle updater, big particle drawer. So now what we're the way we have this function spawn trail, I want to do the same thing with basically blow like with the debris of a block that has been blown into pieces. So shatter block. Do we call it this block? Brick. Shatter brick. Shatter brick. Then it would be nice if we actually accepted a brick. How does the brick look like? Add brick. There we go. Yeah, let's accept a brick. Underscore B. So we're gonna, when we hit a brick, we're gonna shatter the brick. We're gonna actually spawn particles all around this specific brick. So let's see where we're actually hitting the bricks. That's an update function, obviously. Where are we hitting the bricks? Power timers, update ball. Yes, that's good. Check if ball hit pad. Check if deal with collision. There we go. Brick hit equals to hit brick. There we go. We're gonna go to hit brick. So that's where things are happening, where we go hit brick. There we go, hit brick. If it's a B, so I have no memory of what those bricks do. I have to, oh man, I probably should have put in some commentaries. But I think this is the regular, right? Yeah, this is the regular one. I'm gonna just do a shatter brick. I'm gonna do a shatter brick no matter what happens. And then we're gonna go through the individual bricks and see which bricks, because sometimes we're gonna hit a brick that doesn't explode. And then of course we don't want to shatter it. But otherwise we always shatter it. So yeah, shatter brick, spawn particles. And I really need to put some comments in here to remind me what these different bricks do. This B should be brick, but I forgot. I think invincible, so that should do nothing. And H is, whew. Oh, it's a hardened brick, and P is pill brick. S is explosion brick. Okay. Oh, so I got it. So regular brick. Invincible brick. This is hardened brick. And this is power up brick. And this is explosion brick. Cool. So shatter bricks is something we're gonna put in here, right after their sound effect. Not on the invincible brick, not on the hardened brick. Yes, on the power-up brick. And not on an explosion brick. That's something we're gonna deal with by its own. So let me see what a brick actually entails. What do we save in a brick? dx, dy? No, that's ball. Where do we add bricks? There we go. X, Y, V. Value, I guess. Oh, visible. And then T. Okay, got it. So where do we have the width and height of a brick? That's what I wanted to see. Oh, there we go. Brick W and brick H. Good. Okay, so I'm not exactly sure how we're gonna. Let's just spawn like. Let's do a for next loop for I equals. Let's spawn 10 particles when we do this. And we're gonna do the add part, but this time it's gonna be still pixel particles, but they're gonna be different. How? They're going to be just white because I want every brick to explode in the same white color. I think that's a good choice here. So we're just going to do white. We're going to spawn them at you know, not going to be very creative right now. Oops! Oh Jesus Christ. BX. Nothing special here. We make them beautiful in a second. Don't you worry about that. Right now we just this is going to be type number 1. It's going to be a different type of particle. And what is this? This is the age of the particle. The age of the particle is going to be really long. Let's go like 60. But now we're going to add. Whoops! I kicked something. But now so we're spawning 10 particles at the same spot. What gives? I'm checking here because this is where we're checking for different. This is the big particle updater. Okay, so if type equals null equals 0, or type equals 1. Because it's still going to be a particle. It's still going to be a pixel particle. Change colors. Now we want to do for the following. We want to apply gravity. That means also we want to move the particles. So far the particles stay where they are and they don't move. So I guess we want to also move a particle, right? And so this is also a very important part here, where I'm going to put it before the type because it's so important. So we're going to have a dx and dy. So we're actually moving the particles now. So this gets really complicated now. And so when we're spawning these guys in here, so this is where we're spawning the particles or the trail. We have to update this. This is a kind of a little bit of a sad situation here, but we always have to update every add particle call when we're adding some more stuff. There's a way around this, but I want to keep this. I want to keep control over every part of our code. So 0, 0. So we're moving, now we're creating a particle that's not moving for the trail, but here where we're creating a particle where our brick is shattered, we're gonna go RND, let's go on RND4. This is not gonna be looking good, but we just want to have something on the screen that we can play around with first. I wonder if this is even worth. Yeah, it's worth. Okay, so apply gravity. move particle. So let's do the move particle first. This is really easy. We've done this a couple of times already. So p.x plus equals p dx. Y. Okay. So let's see if we're gonna get our moving particles. Now there's a problem here. Plus equals, not equals plus. We should have particles moving, not in every direction, but at least. Yeah, there we go. The black particles. Why they are black? I don't want them to be black. Well, at least we have some particles happening. What's happening? Why are they not? Huh. Oh, we didn't put anything in here. Duh. So this is color 7. So yeah, now the bricks are exploding. They're exploding in down and right because we have a random number generator that goes from 0 to positive numbers, so you're not getting negative numbers. So they're not flying up, they're not flying to the side. But otherwise everything is peachy. So good. So let us now make this a little bit better. So these random number generators, so we did something similar already here. I'm going to use a similar code that we already had. Remember how here we had like this code to spread the particles around the position of the ball. We're going to use the same thing to make the particles go in every direction. So I'm going to put some code in here. I'm going to copy basically the same code. And let's multiply by 2, just by 2, not by the ball diameter. And then we not make it OX, but DX and DY. And then we're going to plug those guys in here. So now particles will go in all directions. See? Now they're splattering in all directions. The only problem is they like flying away and disappearing forever. Let's make them a bit slower. And then we're gonna try something. See, now they're exploding and then disappearing because they're too old. So this is already good. Our stuff is already looking a little bit shatter-ish. But now we want more. I added here apply gravity. Now this is something when I say my students like, oh, make this behave like according to gravity. They could go like, oh no, gravity. How do I make gravity? This is impossible. This is so difficult. I will have to calculate like, you know, slopes, and oh no, this is like going to be some kind of like a sinus and cosinus because you have to have like the smooth movement. Chill. Everything is fine. Gravity is super easy to do. Look. Gravity is only the y acceleration gets faster. That's all gravity is. Every frame, y acceleration gets faster. So p.dy plus equals plus. I have an aneurysm here. Plus equals 0.1. Let's try it like this. So every frame, the y acceleration gets faster. That's it. That's all there is to it. That's all there is to gravity. Now see, our gravity is falling behind, like our particles are now falling down because we applied it to the trail particles as well. That's all gravity is. So the only thing is I want to do is I want to exclude our trail particles. So if we could do it with a type. Yeah, let's go with a type. If p.type equals 1. Easy. So now our trail particles stay where they are, but the burst particles actually explode. Perfect. Let me make mostly brick particles, because I think it's easier to observe what's happening when the level is made out of brick particles, bricks. We have some other levels here. Let's see how this works. Oh no, this is not good. Oh, what is this? Nope. Do I really have to do this? Okay, whatever. Like this. Whoops, what? Oh, yeah, sure. Oh yeah, there's no level left anymore. Okay, good. See? That's beautiful. Doesn't this look awesome? I think it looks awesome. I don't know what about you. So it's color 7. Just want to make sure it's still color 7, because the particle looks a bit dark. But maybe this is just my screen. No, it's here. Shatter break, there we go. No, it's okay. It's great. That looks so satisfying. Okay. So what we're gonna do in the next episodes, we're gonna clean up this effect a little bit. Right now we're having the particles shatter apart. That's good, but I think we can do a little better. For example, the particles should appear all across the surface of the brick, not just like in one point. Right now they're being at the top left corner of the brick. We want to spread them around everywhere on the brick. And maybe we're gonna add some bigger chunks to those bricks, because right now there's just like tiny little pixels. Maybe some of the brick parts are actually, you know, like shards and stuff like that. So maybe we can see about how we can make this happen. So yeah, that's it for now. See you on the next episode, and I hope you will tune in next time. Make sure if you have any questions, you post them in the comment sections. See you next time. Bye bye.